Northern Arizona is home to hundreds of volcanoes. Many of them are the young volcanoes. One of the best known in the region is Sunset Crater, northeast of Flagstaff. Sunset Crater and many volcanoes in this region are about 1,000 years old, pretty new in geological timetables. Northern Arizona is home to about 600 volcanoes, and while these basalt cinder cones are relatively young, there are others nearby that are 6 million years old. The state's most visible volcano is referred to as the San Francisco Peaks.
There are many eruptions that built up that mountain, probably over a period that lasted around 1 million years. So it has a very, very long life compared to a sunset, which may be only as active for a year or 2 or 3.
Wendell Duffield has studied volcanoes for more than 4 decades, the past 26 years in Flagstaff. He says San Francisco Mountain, a stratovolcano, is the highest point in Arizona at about 12,600 feet, but Duffield estimates it was 16,000 feet high.
And then at some point, something happened so that a big part of it is missing. We call it the inner basin, and it's a very large part of the volcano that's missing. And it might have, I happen to believe that that inner basin formed with an eruption similar to what happened at Mount St. Helens stratovolcano in 1980.
Dr. Duffield has authored numerous books on the study of volcanoes, and now he's writing a novel about the peaks coming back to life. In reality, he says that's not likely to happen, but he does predict the eastern part of the San Francisco volcanic field could see more eruptions like that of Sunset Crater.
And we'll know when it's going to happen by earthquakes, because when magma, the molten rock, starts to come up to the surface, it has to break the crust rocks apart to make a passageway, and that generates a lot of earthquakes. And we have scientists in northern Arizona have seismometers out here, so we'll see that and recognize it.
Along with predicting eruptions, another practical application of volcanism is geothermal energy exploration,
which is just the natural heat in the earth. And volcanoes are one obvious marker of all the heat that's in the earth. So I've applied volcano studies to looking for geothermal energy deposits, which can be used to generate electricity, for example.
Duffield has been approached by a geothermal energy company interested in options here in northern Arizona. But this region may be less attractive than other volcanic fields where water from hot springs can be tested before expensive test wells are drilled. Yet Duffield thinks locals might someday be interested in tapping this natural resource.
It would then be possible that an electric plant could be installed to produce enough electricity for Flagstaff, or a lot of Flagstaff's electricity. But somebody has to have the courage or the foolishness or whatever, bravado, to drill a well, find out what's there.
Duffield applied his knowledge of geothermal energy to California's COSO geothermal field, which now produces clean, relatively cheap electrical power for the Southern California power grid. And it's the younger volcanoes, like these in northern Arizona, with the greatest potential for energy production, because the magma is still really hot and at a distance that's not too deep.